We want to find the greatest common factor between 88 and 484. Now, the greatest common factor would be the largest number that divides into both 88 and 484. Now, the way that we're going to do this is to make a factor tree for each one. So let's start by doing the factor tree of 88. So 88, we'll start with 8 and 11. And then 8 goes into 2 and 4. And then the 11, there's nothing else that goes with that. So we'll keep going and we get that. So we get a 2, 3 2s, and 11. So let me write that over here. I'm going to write the prime factors of each one. So for 88, this is going to be 2 times 2 times 2 times 11. Okay, so now we're going to do the same thing for 484. So 484. Okay, now if you're not sure what goes into a larger number like this, you can always begin by dividing it by 2, since the last number ends in a 4, so it's even. So we could always divide that by a 2. So let's do that first. So when we divide that by a 2, we get 242. Okay, well, 242, that is even also, so we'll divide that by another 2. So if we divide that by a 2, we get 121. And then 121, that's going to be 11 and 11. So if I want to write the prime factorization for that, I have 2 times 2 times 11 times 11. Now, the way that you're going to find the greatest common factor is you're going to match the factors on top with the ones down below. All right, so I see here that I have a 2, and 11 on top, and I have a 2, and 11 down below. So this part matches with this part here. So the ones that match, you're just going to multiply those together, and that's going to give you the greatest common factor. So 2 times 2 is 4 times 11 is 44, which means that the GCF is 44, and that would be the answer for that one. Let's do another one of those with this one here. So this time we have 3 different things we want to find the GCF with, but the idea is still the same. You're still going to write out the prime factorization for each one and then find out what factors match. All right, so let's do 100. Okay, so 100, we have 4 times 25. The 4 goes into 2 and 2, and the 25 goes into 5 and 5. So if you want to write the prime factorization for 100, it's just going to be 2 times 2 times 5 times 5. Okay, now we'll do the next thing for 14. Well, 14, we don't either really do a factor tree for that because there's actually only 2 factors of that, just 2 and 7, and that's all you're going to have for that one. And then 35, we don't really need a factor tree either because that's just going to be 5 times 7. So what you want to do here is figure out if you can match anything. Now this problem, if you look here, there's nothing that actually matches. Now we have a couple 7s here, but there's no 7 in the 100. We have some 2s, but there's no 2 down below here. So if you get to a situation like this where none of these actually match, then the GCF is just going to be 1 because that's the only number that's divisible by all these. There's nothing else that will work for this one. So again, if you have nothing that matches, the GCF is always going to be 1.